Okay. So I think all of you guys can see my screen. Okay. This is a presentation that I gave in my company. And through this presentation, we are going to define some basic definitions in machine learning bias. Then we will go a little bit about some libraries we are going to use. So these are the three libraries we are going to use. FairLearn by Microsoft, AIF, it's called AIF, AIF 360 by IBM, and What If Tool by Google. Okay. Okay. What is bias analysis? Sorry, what is machine learning bias? Uh, machine learning bias is defined as following. If you run any machine learning or deep learning algorithm, any artificial intelligence tool to try to create a model, so that tool is going, that algorithm is going to try to find out a relationship between the dependent features and the target variable. And target variable here means, if you are not familiar with these terms, so target variable here is this is the one that we need to predict. So it tries to find out a way to feed in that algorithm with the dependent variables, and then out of the pattern in the independent variable, out of the relationship between the dependent variables and the target variable. So the algorithm try to learn how to make prediction out of this relationship. Okay, so now we are looking for a pattern in the data in order to understand if, for example, if we create a hiring model, for example, to help the HR to hire people. So in this case, the algorithm tries to understand and figure out if, for example, the number of years experience is blah blah blah, is the age is blah blah blah, is the number of children in the household is blah blah blah, is the previous income is blah blah blah, and so on. If it is male or female, if it is the ethnic group, what ethnic group does he belong to, and so on. So he tries to understand all these kind of features and try to make a prediction based on these dependent features if this guy deserves to be hired or not. Okay, so this is the meaning of machine learning algorithm. Tries to find a way to make prediction using these dependent variables. But for example, in this specific case, in hiring system, so it does not make any sense to hire people based on if they are male or female. So if we do so, we are violating laws in the United States or any other countries, and I'm going to come to this later. Okay, so we violate the law here because our system is biased, and it returns the prediction based on features. One of these features is male or female. One of these feature is black or white. One of these feature because this guy is married or not. So this is biased model. And one of the very famous issue happened about machine learning bias. It was, I think, I read the story. I think it was Amazon people created a model maybe 10 years ago or so, and I don't remember exactly what that model was about, but the model was very biased, and the company at that case was sued by a number of people because their system is biased, and that costed the company lots of money. So if I find out a video about that story, I will share it with you guys. So this why the machine learning bias issue has been very important for all the companies not to just violate any law by creating a machine learning model. And a machine learning model, by the way, it's not the thing that has the final word in anything. For example, in hiring systems, so it just helps the HR, but the assistance here has to be fair assistance in order for the HR to trust the prediction of that model. Okay, so now we need the algorithm not to be biased against some groups or against some groups in some features. What do you mean by some groups in some features? Like, for example, if the data, because you know that machine learning algorithm get trained on, we train the machine learning algorithm on a set of data, on a data set, and assume, for example, in this data set, in hiring, especially for higher level positions, assume, for example, we are hiring for managers, and most of the people in the data set in the manager position, most of them are males, not females. So in this case, the algorithm by default will be biased for males against females. So most likely it will say yes on most of the males and no on most of the females, because the algorithm has learned a lot about the males than females in making the prediction here. So in this case, uh, our model is going to be biased. Okay, and this what we don't want we don't want to get here in this case. So in this case, we need to make the algorithm not to hire people based on the gender. Okay, we don't want let me rephrase. So we want the model not to bias for one group against the other. So the group here is male, female, the feature here is gender. Okay, so according to the law, the maybe the federal law, the state laws, the law of the company you are working at, so based on these laws, you they will provide you some features, and these features will be called sensitive features. So they'll provide you with some features and tell you, okay, try to make our model to be fair about about these features, which means try to make your algorithm to make prediction, but not to make prediction based on these features, based on male, female, black or white, blah, blah, blah. So one might say, oh, okay, so simply we can just to drop these features out of from the data set. So in this case, the algorithm will not learn anything about these features and will not make prediction based on these features. But unfortunately, this is not a good choice, because the model is, because, for example, let me just give you an example. Because the data set is going to be is going to have some uh, okay. So let me just pick up one of the features, one of the sensitive features, married or single. Okay, married or single. uh, Such a feature like this might have impact on other features. Yes, it might have impact on other features. Like what? Like, for example, if married or single, okay? And I decided just to drop this feature because I need the algorithm to be fair about this feature, not to decide if this guy will hire or not based on married or single. So simply we can just drop, but no. If there is married or single column in your data set, so this can impact other features like what? Like age. So most of people under maybe 25, 24, 23, most of them will be single, and maybe above 30, 35 are married. So older people most likely will be married, and younger people most likely will be single. The the house size, if you are married and most likely you will have children, so your house size will be bigger than the house size of a single. Number of children, of course. If you are married, most likely you have some children. If you are single, most likely you don't. So you see that married here, the married or single here, impacted the other features. So if you decide to just remove that feature, so still the impact still there in the data set and can be detected and can be captured by the algorithm. So still the bias is still there. And for example, black and white. If you decide to drop just black and white like that, you will find other features that impacted by black and white. So some history, maybe some cities that have majority of black or majority of white, maybe some zip codes that have majority of black or majority of white, and so on. So the solution is not just easily just drop the feature and that's it. No, this is not true. So we just keep the feature in the data set, but we try to find a way by using these libraries. We try to find a way to just try to reduce, first to identify the bias, and then second to reduce the bias. Okay, so this is the definition of machine learning bias. This is the problem. Is it's just scattered the impact of the sensitive features are scattered through the entire data set. Is not it's rooted in the data set itself. Okay, so this is the definition of bias and sensitive features. We have different types of bias, and so we have bias comes from people themselves, because we people work on creating machine learning model. We people work on collecting data set. So I might be biased person that maybe collect more data for white than for black in order for the model to learn more about white people, not on black people. So this is called social bias. And there might be bias comes from statistics. If the number of records in your data set is not large enough to be uh, to 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 collect all information. But so this bias creates harms. Sorry, this bias. Yes, so this bias can create harms. Harms. What does it mean? Harm. Harm here. So it means misusing of the model. Misusing of the model. Like what? Like. Number one, for example, is allocation harms. If you create a model that where the model is biased, and this is a hiring model, so the harm here is the model is going to allocate improper person in the position and remove a proper person from that position. So this is called allocation harms, and this is mostly useful when we come to a classification model, yes or no. So the model will say yes on a person he was supposed to be no, and will say no on for a person that was supposed to be yes. Quality of service harms, and this is not the only harms, by the way. So there are some harms, and I put some references here. So quality of service harms here. So if you create a biased model, the service that model will introduce uh, is going to will offer is going to be uh, incorrect. Like what? Like for example, and I think this is a famous example. If you create, for example, a computer vision model to detect face detection model, and that system is going to detect faces. Okay, out of just the input here is pictures for people, and the output here is prediction. So who's this guy? And some models, and I think that was real model. So some models just classified black people as monkey. So that was a bad quality of service, a bad quality of service provided to certain group of sensitive feature. So as we said, sensitive feature is, for example, gender, and the black and male, female is the groups within these sensitive features. So these are the harms, the bad thing that happens out of the biased models. Okay. Model fairness, sorry, machine learning fairness can be classified under two main groups. One is the two main classifications, two main classes. I mean, one is group fairness. Second is individual fairness. Group fairness means the model in average in average within males and females, in average, the model is fair. Not for each individual person, but in average. Okay. But individual fairness here, it means the model is fair about each single individual person in that group, which means if, for example, we have same CV, exactly same CVs, and we just change one single feature from CV1 to CV2, which is, for example, male to female, and we provide these two same CVs to the model is going to say yes on one and no on one because just the change in the group of these features of the gender here, okay? So this is individual. This is how to test if the model has individual fairness or not. We provide same thing, we just change the one feature for these two groups, for these two individuals, okay? But group just trade the groups in average to find out if there is fairness or not. The algorithms the libraries we are going to use, they are going to have metrics, and I'm saying because this word will be repeated very frequently, metrics, not matrix. Okay, metrics, METRICS. Metrics here means the measurement. Okay, so the measure we use to say if there is fairness or not, if there is bias or not, because we have several metrics. Okay, not matrix, which is mathematical object. Okay, so we have in each library we are going to have several metrics that will measure the group fairness by itself and individual fairness. Okay, so we are going to classify the metrics based on group or individual. Okay, the machine learning bias can be tested in three different stages of the machine learning life cycle. Number one, the data set itself can be biased. Can be biased by, as I said before, we can collect more males than females. We can collect more whites than blacks. So in this case, the model will learn more on the data that have imbalance. If there is imbalance, if you remember one of the terminologies used in my program of, I mean, UT at Austin. Okay, so if there is imbalance in the data for one of the features, so that means the model is going to learn more on one group than the other group. Okay, so now we need to test the bias in the data set. Okay, and this is the first step. Third step. First step and the third step is the model prediction can be biased. And even if there is no bias in the data set, everyone knows that machine learning algorithm is a black box, and we don't know so much about what's going on inside that black box. So you can just have fair input, which is the data set, but still the model is not fair. So there is bias can happen in the model prediction, and we have metrics to measure that bias. And then in between step 1 and step 3, so we have step 2. So step 2 is the learning algorithm itself. While the algorithm is learning about the data set, it can cause bias. But to be honest with you, I have not done any work on this stage. I worked on machine learning bias. I worked on the data set bias and machine model performance bias. So stage number 1 and stage number 2. Okay, so for all of these three stages, we have, especially just drop the middle one for now because I don't know much about it. But for data set and model performance, these are the two main parts we need to just focus on. So for data set and the machine and the model performance, we have metrics to measure bias, and we have algorithms to mitigate. Mitigate here means reduce, but the word mitigate has been used here very frequently. In order to mitigate the bias, using these libraries, using these algorithms to reduce the bias and make the machine learning model to be fair. Okay, so one more time, we have metrics and mitigation algorithms for dataset, and metrics and mitigation algorithms for model performance. Okay. Okay. So there are two world views, two different world views for group fairness. So one might say, okay, if you have collected data, and the data you collect is called sample, and the entire data in the world is called uh, population. Okay, let me just give you an example. In a company, for example, you have, for example, maybe five 5 million records on uh, the server, okay, on the SQL data on the database. Yeah. So you have, for example, 5 million records on the database, and this is the entire data the, that out there on the database to work on. And when you come to train your model, you're not going to train your model on this big size data set. So you're going just to sample the data. You're going to pick up your data out of the 500 million records. Okay, so when you choose your data, you have to choose it in very random way. In order for your sample, the entire data is called population, and you are going to sample your data. You are going to pick up you are going to collect your data out of that huge amount of data. Okay, so in this case, you need to, and there are some, I think there are a couple of different ways to how to collect data in random ways. Okay, so everyone watched my program did not get to that point, because in all the projects they just provide you the data set. But no, sampling the data set is important as well. So you can just, and I think if I find a good video for that, I will share it with you guys. And it's just simple. For example, you can just say, okay, I'm going to take, for example, row number 1, then skip 9 rows and take row number 10, then row number 20. No, so randomly you can just pick up samples like this from the entire data set. Or you might say, oh no, I'm going just to take, for example, 10% of 50% of my data comes from male, another 50% from female, and so on. So you can decide what percent you need to take for each subgroup from each feature, and so on. Okay. So there are different ways to collect data, but at the end of the day, so let me just say that you have collected your data, and you have found that most of the managers are males. So does that mean, and the most important thing here is that your sample to correctly reflect the population. Okay, to correctly reflect the population. This is the most important thing in collecting the data set in very random way. Okay, so you need your data set to correctly reflect the population, and assume the population, most of the managers are really female, are really males. So, and we need your model to learn that. So isn't fair for the model to recommend more males for the manager position than female, since the majority is just males? So this is one view. So this view says that uh, let me just read with you here. So the WAE worldview holds that all groups have similar abilities, not this. So this worldview holds that the observations they reflect ability with respect to the task. So this approach here just adopt this kind of uh, of uh, this kind of worldview, is that since the data set since you have collected the data set in fair way and in very random way, statistically random, so since you have found more males and than females in the manager position, so this what is there. So and we can just go with that. So this is one approach. The second approach says that okay, even if the population has more males than females in the manager position, still for each individual incoming applicant, it's not fair to say this guy can be manager than this lady just because the history says that. No, each single applicant is just a population by itself. Each single applicant is a population. So don't reflect what is there in the population on this applicants in front of me. I have male and female applicants, and I want just to make a decision based on their skills, not based on the history in the population. So these are two approaches, and I think the approach we have adopted here in my analysis is the second one. Sorry, it's the first one. So the world view holds that all groups have similar abilities with respect to the task. So we don't make decisions on these individuals based on the history out there in the population. So all of them have to be equal. Okay. Okay. We have different metrics to measure the to measure fairness in the WAE world view, and these metrics are called demographic parity metrics, and so this is the metric that we are going to discuss later. And for the other approach, we have different set of metrics can be used. We'll discuss some about this. Okay, mitigation here we have, as I said before, we have some algorithms to measure the to reduce bias if we have found bias. And when you say I got bias in my model performance or I got bias in my data set, so this has to be decided by a machine learning board in your company. So what I have done here so far is I ran the analysis on the data set and the model performance, and I just shared with them my numbers, and I said, oh, I found, for example, the demographic parity difference is blah blah blah. I found this metric is blah blah blah. That metric is blah blah blah. And you guys, these are my numbers, and you guys decide if these numbers are fine with you. Are you okay with that? And you can assume this is just small numbers and might come from just statistical uh, perturbation or something, or they are real bias exist in the data set or model performance. So you can just they decide on that. And if they decided that these numbers are fine, and this what happened in my case, so we don't use mitigation algorithms because we don't need to reduce bias. So the bias is small and not causing any harm. And if they decide no, there is intrinsic harm, intrinsic bias in your model, so we are going to use we should have used the mitigation algorithms in this case. Okay, but we did not in my analysis. I did not use mitigation algorithms, and the mitigation algorithms have three different stages to work on: pre-processing, which is the data set; in processing, which is the learning algorithm. During training the model, there is algorithms to work on reducing bias in during training the model, and after completing the model and while the model in production to make prediction, this is called post processing. So there is pre-processing, which is data set; in processing, learning algorithm; and post processing, which is the model performance. Okay, and they have techniques in reducing data sets. Okay, and these techniques just in briefly I will just give you, because each algorithm has different techniques. So these techniques can be summarized as following: if the mitigation here is working, even either matrix or mitigation algorithms working on the data set, so they measure the distance between the data points. Okay, so something like if you plot 2D diagram, and you have 2 points in the 2D diagram. So assume, for example, the x-axis is feature 1, y-axis is feature 2, and you have 2 different data points, and that row has certain values for feature 1, feature 2. The other point has another value for feature 1 and feature 2, and then you can represent these 2 data points in the 2D diagram. Okay, so this is just simple example, and of course you have n dimensional space for the features. So the feature space can be any number. Okay, and all the data points can be represented in that n dimensional space, and then they measure this matrix, measure the distance between the data points to see if there is bias or not in the data set. Okay, so this is just roughly speaking, and this about the metrics used for measuring for measuring the bias in data analysis. And then the mitigation algorithms are some mathematical equations can be used to trying to reduce the distance between the data points. And for model performance, I will come to some definitions of metrics for model performance. Okay. So mitigation algorithms are not the only solution to make your model fair. All these techniques are not the only solution. These are just technical skills or technical tools that can be used. But the social bias, because social bias in collecting data, because human collect data, and if I am biased person, so I will try to skew my data to be biased. And at the end of the day, after the prediction, model prediction, who takes the final decision here is not the machine learning model, it's a human. And machine learning system is just assist the decision makers. Okay, so even if I am I'm sorry. I am the one that will make the decision, so I can be biased, even if the model is not biased, I can be biased and take a biased decision. So this is not the only solution for removing bias from the entire system, not just machine learning system, but from the entire system of decision making. Okay, and okay, so the libraries I have used is FairLearn, and this is my experience with machine learning bias. I used FairLearn and AIF 360, so I did not use What If tool, Google. So this is what we are going to learn together. And in FairLearn and AIF 360, I have used metrics to identify bias. I did not use mitigation to reduce bias. This is my experience with that. Okay. Uh, so some facts about Fairlearn. So which one is better? So I worked with this Fairlearn and the F3. Fairlearn is really very poor library. And this is a library that was given to me to work out the bias analysis in the company. And this library just has one metric to be used, which is the we will come to that metric. Okay, it just has one metric to use for measuring for identifying bias. And as I said before, bias can be classified into group fairness and individual fairness. Bias can be identified in dataset or model performance, but just in FairLearn, they introduce one single metric, and that metric, as I said here, so it tests just group fairness only. Uh, and FairLearn can work with classification or regression. And so this is just okay. So this is just for group fairness only and model performance only. So it does not provide any metrics or mitigation for dataset, bias in dataset, or individual fairness. And this is what the other library does here. This is why we went to the other library. I suggested to use AF360, and my manager approved my request. So in IF360, they provide lots of metrics, not just one. Lots of metrics for dataset, lots of metrics for model performance, and so dataset and model performance, and then group fairness and individual fairness. This is what we are going to do. We are going to divide it into 4 parts or 4 classes: group, individual, dataset, model performance. So we are going to split the matrix into this classification. Okay. So these are the metrics used in FairLearn to use to measure the fairness in the model performance. I told you how the metrics work in the data set. They measure, most of them measure distance between data set. But for model performance here, what happens here for this metric is called demographic parity. And this E here is the classifier. Okay. Sorry, E here is the probability. H here is the classifier, X is the data set. So this is the probability or the prediction. It can be considered as probability or prediction. So the prediction of the classifier, when we fit the classifier with a data set X, and here is the prediction when the classifier picked up this data set, where A is the sensitive feature. Okay, A is the sensitive feature like gender. And in this case, A here is equal to one group and A here equal to another group. Like A is male and A equal to female. So is the predictions going to be the same? This is the question. So the prediction for the classifier when gender is male. Prediction for the classifier when gender is female. Are they going to be equal? If they are equal, they have zero bias. If they are not equal, in this case, so this is called demographic parity. And the other one is similar, but exactly similar. But here we just pick up. We have here this. We specify here the output to be yes, the output to be no. I think there is y prime on this instead of y. Okay, so if we or no, I think so. We do so. We will pick up gender is male and gender is female for yes, this capital Y is the output, or for no. Okay, so this is another metric. This metric, demographic parity here, measures the allocation harm, and this metric here measures the quality of service harm. Okay, so now if there is difference between these two numbers, we can find this difference in terms of subtract this by this. If the subtraction is zero, if the subtraction is zero, so the fairness is, sorry, the bias is zero and the fairness is 100%. If the difference is not zero, but close to zero, still fair. And this is the limit or the boundaries that the company will decide, the machine learning board will decide if your numbers are still fair or not. So you can measure the difference of these two numbers, or you can measure the ratio. If the ratio is 1, so that means this equal to this. Okay, and this is called demographic parity ratio. So you can pick up any of these two metrics, either demographic parity difference or ratio. Okay, so mitigation algorithms, there are 4 different mitigation algorithms for FairLearn. I'm talking about FairLearn. Okay, so one of them works on the pre-processing to remove correlation. And how does it work to reduce bias? As I said before, if for example I have gender male or female, this might have impact on other features. Okay, so in order to reduce the bias that caused in the features by gender, one more time, in order to reduce the bias, in order to reduce the impact of feature of gender, in order to reduce the impact of gender on the other features, we can try to reduce the correlation between the features. If we reduce the correlation between all other features that has with the sensitive feature, the correlation between the sensitive feature with all the other features, in this case, the impact on the other features will reduce. And in this case, if we even remove the gender from the table, so that means we have got rid of the gender and its impact throughout the table. Okay, so this how it works for pre-processing on dataset. Okay, so other mitigation algorithms work on post-processing, and this for the model prediction after you create the model. So the classification here, the classifier here makes a prediction, and this prediction can be biased. So what happens here for this mitigation algorithm, they take the algorithm, they take like the classifier, okay, this is number one, and they take the sensitive feature as inputs. Okay, so one more time, the mitigation algorithm for post-processing, which is model performance, they take the classifier and they take the sensitive feature as an input to mathematical equations. Then they try to play with the prediction of the classifiers to make the prediction as the output of this algorithm, make the prediction make the prediction to be fair. Okay, so as I said, it is just like a box, and the input is the classifier and sensitive feature. Inside this box, there are some equations. The output of the box is the prediction of the classifier, but to be fair. Okay, to be fair. uh, and inside the box, there is something called parity constraints, which are mathematical equations. There are some limitations here, and so the limitations here is that we don't know exactly what happens. Uh, Let me just read through. So group fairness metrics are observational, and they don't consider how the prediction was achieved. Oh, okay. So the metrics, we don't know exactly. So if we have metrics for model prediction, so the model prediction like this, like here. So this we subtract here. We subtract the prediction of the model, this minus this, one for male and the other for female. And we don't know how this prediction was made. Okay. So if we don't know what features that has more importance than others in making this prediction. So we just take the prediction and plug it in here without knowing anything about the history of that prediction and how it was made. Okay, so this is limitation on the on the matrix. So it does not give complete picture of what you are interested in, and it discards individual experience. So for just for fair learn, it does not do individual fairness, but for AIF 360 it does. The features we have worked on according to the law and the rules of the company is gender, ethnic group, household income, age, state. So we can work on the same in our analysis. We can work on the same features, that's fine, but we are going to just pick up one of the uh, data sets on the online, okay? Okay, I think that's it. Okay, so here on this website, so I'm going to share with you guys the websites. Let me just hide this. So I'm going to share with you all the websites for these three libraries and some resources. So this for this Fairlearn, for example, and in Fairlearn, these are the mitigation algorithms. So if you click on any of these, it will show you the syntax. How can you write this? And maybe some examples here or so. And there is GitHub for all of these libraries, so you can find details about how to write the syntax. Writing the syntax, by the way, is one of the very difficult tasks in doing this bias analysis, especially for AIF 360, because here it's more straightforward, just one metric. And the metrics have been used for using Fairlearn is demographic parity, and you can find some details about the parity here and an example how to write the syntax of that. Okay, for AIF 360, there is this website is very comprehensive. It has some information, some web demo videos on YouTube on how to use. So they have very good tutorial videos, some original papers, because what IBM does here, it collects some research papers with from researchers and just adopt some of them to include it in their libraries. Okay, so this read paper, it's just research papers, and we might need to go to. I did that in my analysis. So you might need to go back to these research papers to understand the meaning of some metrics and how to use some tutorials here. If you ask question on Slack, okay, I think view notebooks. I think this will take you to GitHub and blah blah blah. So this is the important website for AIF 360. This is where you find uh, the syntax of all the metrics. Okay, if you go here for fairness metrics, you can find number of fairness metrics here, and you know that in Python when we use pandas, the type of data is called data frame. But some metrics here are built based on different types of data set. So this, for example, is called data matrix, binary label data set, blah blah blah, classification metric, blah blah blah. So these are classes for computing metrics based on different types of data set, not just. So this is the main source of difficulty in using AIF 360. So you have to convert the data from data frame to this type of frames, this type of data set, and then you use the metrics for each class of data set here. There are certain number of metrics you can use based on this data set. So that means if you convert, for example, your data set from data frame to this binary labeled blah blah blah. So under this binary labeled blah blah blah, we have this list of metrics. Okay, this how to use the metrics. And this is the syntax of converting the data set from data frame to binary label data metric, blah, blah, blah. Okay. And these are the metrics. For another one, we have another list of metrics associated with this data frame and so on. The algorithms here these are the mitigation algorithms will be used. And this is GitHub. And I am done. Any questions, guys?
So we'll just use this GitHub and the libraries to develop the models.
Number one, we are not going to do anything with this now. So in the next 2 weeks, I want you guys to read background, just go through my PowerPoint slides again, read the review article I give you, because most of the information here comes from that review article. And just in 2 weeks, just focus on this. Because now I have prepared you for, you are done with the background of artificial intelligence, either machine learning or deep learning. Then you need to get background on the bias and machine learning bias. Then we start our project by just applying. We are going to pick up data after 2 weeks. We're going to pick up data for each of you guys. Then we decide what data will be used. We decide how to, or not decide. So we will use the 3 libraries on your data set. We start real work after 2 weeks. So don't
Okay.
do anything with these websites now. And for Karim, for example, he's going to do tabular data. And because tabular data is the easiest out of text for a MOG, because he's going to create an NLP model. And the most difficult is images, computer vision for Muhammad. So this is why Karim is going to create, and this is, let me complete. So Karim is going to create 2 models. One using the classification algorithms from machine learning, traditional machine learning algorithms, using session tree based algorithms and blah, 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 and then create another model in deep learning. So out of this, and this is my hope. My hope is after we finish this project, this will be really a very good techniques you have learned in machine learning. So that will help you joining any industry with real experience. So if we make our notebooks really comprehensive like that, all of us, we can use it in any job, any company. Okay. So this why when how much time did I put in creating that analysis? Lots of time, maybe a month and a half or so, trying to understand the bias, trying to read through the review articles, some research papers for AIF 360 metrics. So I put lots of time just to use Fair Learn and AIF 360 just for the metrics, not even the mitigation algorithms. So if you guys go to apply to any job and say, okay, I have learned these three libraries and I can use it in any task, machine learning, classification, net NLP, computer vision. So you are superior in this field. So this is really, and one of my colleagues, Muhammad knows Hazim. So Hazim has more experience than me. So as I said, I just started last year, but Hazim is really senior in his work, and he's expecting that in the future, maybe in the near future. So new positions just for hiring people for just machine learning fairness. So these positions will be out there in the market maybe in the next couple of years. And this I expect because in any machine learning, any company that use machine learning or artificial intelligence tools, they have to have these fairness techniques. So this is why this project is not research oriented, and this is the beauty of this project. Not because I am the one that created that project, but it's not research oriented, but it's more industry oriented project. And sorry if I speak a lot. Any other questions, guys? Okay. So now you have the stop sharing and stop. I think stop recording.